We've talked about the 4 pillars of object-oriented programming, and we've also looked briefly at unified modeling language class diagrams, in which we show the properties or attributes of the class and the methods of the class using a charting standard within the unified modeling language. Here I have the pet class. We see some properties of ID tag, pet name, birth date, gender, spay, neuter, and vaccination, and the methods of new, calc age, and vaccination reminder. What I'd like to do in this video is talk about and demonstrate how we see the 4 pillars within the UML class diagrams. We'll start with encapsulation. We've seen we can have public properties and private variables, and we can have methods that are both public and private, and that is part of encapsulation. It's this idea that some things are hidden from outside of the view of the class. That data is encapsulated. There's another aspect of encapsulation, and that is this idea of the black box. We have a method in this case called calc age. From outside of this class, we can call that method, since it's public, and have it return a double value, which would be the age of the pet. However, how that age is calculated is really of no consideration for us. Those inner workings are hidden. There might be different ways of calculating that age, but it doesn't matter as long as we're getting the right response. That is also encapsulation. We're not seeing how the inner workings function. Oftentimes we have multiple classes in a project, and sometimes those classes are related through a process called inheritance. Let's take that pet class we just looked at, and we're going to call that our base class, or some refer to as our superclass or parent class, and then we're going to create inherited classes, also referred to as subclasses or child classes. Those inherited classes further implement the base class. For example, here I have a dog class, a cat class, and a horse class, and there may be properties and methods that each of those subclasses have that are not necessarily consistent through all the subclasses and could thereby be put in the base class. So the base class contains the properties and methods that are common amongst all of the subclasses, but each of the subclasses have further properties and methods that are unique. For example, for the dog class, we have an AKC Boolean property, whether the dog is registered with the American Kennel Club as a purebred. That's not going to apply to a cat or a horse. Same way with a cat, we have a property called indoor-outdoor both. Is it an indoor cat, an outdoor cat, or one that goes between the indoors and outdoors? For a horse, we have a property called hands height. How tall is the horse in hands? It's a double value. We don't talk about using hands to measure dogs and cats. When we create a child class, we declare the public class and the name of the class, and then we say it inherits from the base class. So in this case, public class horse inherits pet. Public class dog would also inherit pet, as would cat. Now, an important thing to talk about here is the constructor. So I have a constructor in the pet class. It's taking variables of an integer, a string, a date, a string, and a Boolean. I'm sorry, I missed the vaccination. There should have been a 6th one to the vaccination. And it's setting those properties to those values. However, we normally don't instantiate an instance of pet. We could, in this case, but more likely we're going to create instances of dog, cat, and horse. The horse also has a new constructor, and in that constructor, we're passing those same values that are part of the base class as far as the ID, the pet name, the birth date, the gender, the spay, and like I said, I missed the vaccination. That should have been there. And then we're also adding to that the variables being passed for the properties of the horse. Equine type, whether the horse is broken or not, and its height in hands. What we do in the body of that constructor is we pass the variables that are part of the base class to the base class constructor. So I call mybase.new and pass it the ID, the personal name, the birth date, the gender, and whether it's spay or neutered. And then I set the properties for the subclass, or the child class. So equine type equals AT, broken equals BR, and hands height equals HH. The advantage of inheritance is I can create a list of type pet that includes all of its child types or child classes. So my list of pet can include a dog, it can include a cat, it can include a horse, each with their own properties and methods built in and available to calling an instance of that class. The word polymorphism comes from the root of poly meaning many and morph meaning form. So polymorphism means that our methods can take on many forms. So in the dog, cat, and horse, I have a method called writeRecordCSV. It's the same name in each class, but how it's implemented and what it returns as far as the string varies between those three classes. It takes on a different form in each one of those three classes, yet it's named the same. So it doesn't really matter whether I'm working with a dog or a cat or a horse, maybe in a list of instances of type pet that include those subclasses. I can call the writeRecordCSV and it will return the correct string for that type of pet. There's another type of polymorphism called overloading. Here we have two methods of the same name within the same class. In my case, they're both constructors. They're both new methods. But what's different between them is the signature. And when I say signature, I'm referring to the parameter list and the data types of that parameter list. So in the first one, I am passing it a string, a string, a string, and an integer. And it's setting the last name, first name, major, and class standing. But in the second constructor, I'm not passing the class standing. The parameter list only includes string, string, and string. And that sets the last name, the first name, the major. The class standing, though, I set to a 1. And that 1 represents a freshman. So 2 would be sophomore, 3 junior, and so forth. The reason I do that is in creating a new student, I know that most students coming in are going to be in the class standing of freshmen. I don't need to specify that. It's just one less thing I have to type in or choose, maybe from a combo box. I can just say, hey, I'm adding a new student, and the student is a freshman. Just set the class standing accordingly. The programming language knows which constructor to use based on the arguments being passed to it. 3 strings and an integer, it calls the first one. If there's just 3 strings, it calls the second one. Now, one thing to point out here is we can't have another new where we're passing it, say, first name a string and then last name a string and then major string. It's not going to care what the variables or the order is. It cares about what the data types are. So I can't have another new method that is passed 3 strings. It's got to be different data types. But I could have one that specifies a string, and an integer, and we'll say the major is going to be always computer science and make that our default. And then we have a different signature. So I could have 3 new methods in this class. An abstract class is one that can't be instantiated because it contains an abstract method or several abstract methods. In the UML diagram, an abstract class's name is in italics. An abstract class creates a base that must be inherited by a subclass. So here I'm going to take pet and I'm going to add a method of make sound. And I'm going to specify that that method has to be inherited or overridden in the subclasses. Now in each of those subclasses, dog, cat, and horse, before I had a bark method, a meow method, and a neigh method of those 3 different subclasses. I'm going to replace those with one that says make sound. And in the dog class, it's going to return a bark. In the cat class, it'll return a meow, and a horse will return a neigh. The advantage of doing an abstract method like this is it forces me to make sure that I include that make sound method. If I don't, I will get an error. In creating the abstract class, which is going to be our pet class in this case, we add the word must inherit in the declaration of the class. So I have public must inherit class pet. And then I can specify an abstract method by using must override within the function definition. So I have public must override function, name of my function is make sound, it's going to return a string. Now, one thing to point out here is in that abstract class, we don't give a body or an end sub or end function to that class declaration. It's just that one line. In each of the subclasses, I'm going to include that function called make sound, and I declare it with the keyword overrides. So public overrides function make sound. So we're overriding the function that's in the base class, and we're going to return something. So we'll return either a bark, meow, or a neigh, depending on the class, and then my end function. So this one does have a body and has an end to my stub. The advantage of abstraction then is that I can call that particular method from a list instance of type pet that is a subclass of either dog, cat, or horse. In the next video, I'm going to introduce our project of maintaining an inventory for a hardware store. And we're going to use in that project encapsulation, inheritance, polymorphism, and abstraction. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.